Okay, in this problem, we're looking at the limit as x approaches 2 of this expression right here. Notice we have a complex fraction. We have fractions inside of a larger rational expression. Okay? So the first thing we do, as always, is to check and see what are the limiting behaviors of the numerator and the denominator. Are we dealing with a continuous function here, or at least a function that is continuous at 2, where I could evaluate this limit just by plugging in 2? Well, if I were to find those limiting behaviors of the numerator and the denominator, if I were to plug in 2 in the top and bottom here, what would I get? Well, the top, 2 times 2 cubed, that's 2 times 8, that's 16. Minus 16, that's going to be a 0. And in the bottom, 2 over 2, minus 1, that's also going to be 0. So it looks like I have an indeterminate form. Yes, this expression is undefined at 2 because of the presence of this 0, but the fact that I also got a 0 up top tells me that it may be the case or it may not be the case that this expression has a limiting value as x approaches 2. I'm going to need to do some more work. Ideally, perhaps, we would have some sort of factor that was going to 0 as x goes to 2 in the top, and similarly something like that in the bottom, a factor that's going to 0, and maybe that factor is a common factor and it could be canceled off. And either what we would have left we could find the limit of, or we would know that the limit as x approaches 2 didn't exist at that point. Okay, we simply don't know which one of those cases it's going to be, but perhaps we can find some common factor to cancel off. Well, how can I go about looking for that common factor? The top maybe I could play around with and factor a little bit, but the bottom looks a little bit ugly, doesn't it? With the presence of this little tiny fraction inside the denominator. Let's try to clear that first. Let's try to simplify this expression and see where that leads us. And one way to simplify expressions like these, where you have fractions inside of fractions, is to look at all the denominators you have, and here we only have one with a denominator of x, and multiply the top and bottom of this larger fraction by the common denominator of all the little denominators you have. Okay, so since we just have one, we'll multiply the top and the bottom by x. Okay, so we have something like this. Make sure you put the parentheses in, because if you will have to distribute this x to both of these terms, and same thing down here, and they'll help you remember to do that. Okay, so if we do distribute this across here and this across here, notice x times 2 over x, the x's cancel and just leaves a 2, and x times the 1, of course, is just an x, so we should get something like this. Okay, so we've got our 2 minus x in the bottom, and of course the top is dealt with in a normal way. X times 2x cubed is 2x to the 4th, and x times negative 16 is negative 16x. Okay, now the fractions inside of fractions component of this thing is now gone. So maybe we'll have some better luck looking for a common factor, top and bottom. Of course, that requires that we actually factor the top and the bottom. The bottom, there's not much to do, so let's focus on the top now. What can we pull out? Well, isn't there a common x on both of these terms? Couldn't we start there? For that matter, not only an x, but a 2. If we pull both a 2 and an x out, we're left with, notice, x cubed minus 8. Okay, we still don't have a cancellation yet, but all's not lost. X cubed minus 8, you should remember that form. This is just a special product rule, right? A difference of 2 cubes, like we have here. A cubed minus b cubed, remember that's a minus b times a squared plus ab plus b squared. That's something you should have committed to memory, most likely. It shows up in enough problems where that becomes useful to do. Here, notice the first term is the cube of x, and the second term is the cube of what? Well, that would be 2. So shouldn't we be able to factor this as this, right? A is x, b is 2. There's a minus b, x minus 2. There's a squared, or x squared. There's the product of the 2, right, ab. So 2x, and there's b squared, or 2 squared, or 4. Okay? Notice now we see something. This factor right here and this factor right here are really close together, or close to one another. They're only off by a sign. Look, positive x here, positive 2 here, negative 2 here. If I pulled out a negative from this, then I would get exactly this factor here, and so those would then cancel. So that's what I'm going to do. I first pull out a negative, that makes that negative x plus 2, and then I cancel. Okay, so what we have left is just this. The limit as x approaches 2 of negative 2x times this quadratic piece. Notice there's no denominator. There is nothing that will cause a 0 in our denominator anymore because we don't have a denominator anymore. Okay, if we were to simply plug in 2, we are looking basically at a polynomial. Polynomials are continuous functions. Limits of continuous functions can be evaluated just by plugging in the corresponding x value. So that's what we do next. Plug in 2. So we have negative 2 times 2 squared, or 4, plus 2 times 2, or another 4, plus a final 4. Multiply all that out, and we have negative 48. Now, what does that mean graphically as to what's going on in the graph of this function right here of y equals this expression? Well, the limit existed. So as x approaches from the left or from the right, the value 2, the height of the function, must be getting arbitrarily close to a height of negative 48. Okay, notice we haven't said anything about what happens at 2. The limit only describes what's happening to the immediate left and the immediate right of this x value. However, we know from this earlier calculation that if we just tried to plug in 2, we would get an undefined value. So there is actually a hole here, and that is our graphical interpretation. We have a hole at 2, negative 48, that's the coordinates there, in the graph of y equals this expression. Okay, so the value of the limit is negative 48. There's a graphical interpretation if we need to have it. That's it.